All right, so let's go ahead and do this example. So we want to find and classify all the critical points for this multivariable function. All right, so without having to graph it or anything, let's go ahead and find our critical points, because that's usually the first step that you want to be able to do. So let's first start off by taking our partial derivatives. So we're going to have f sub x, right? And this is going to give me, so we're going to have 3x squared. That goes away, and you have minus 3y. Right, so that's going to be our very first one. And then we're going to take our, and set it equal to 0. And we're going to take f sub y. And that would be 3y squared minus 3x. Set that guy equal to 0. All right. Now, something that would be really useful also would be to kind of also find the second partial derivatives. I'm going to go ahead and do that also. So I'm going to set them to the side because we will have to classify them using the second derivative test. So I'm going to take the second derivative with respect to x, the partial derivative. So this will be 6x. The partial derivative with respect to y, that'll be 6y. And then the mixed partial xy. So we're going to starting off here, take the derivative with y, that's going to give me negative 3. Okay, so we'll keep this in the back burner for now. All right, and now let's go ahead and solve the system of equations. So I'm going to solve for this. So I'm going to add the 3y over. So you're going to have 3x squared equals 3y. Divide by 3, y equals x squared. Okay. So now what we want to do is that, you notice we have two systems of equations. We have to plug in the other one into the other one. So to use substitution. So we have 3. We know what y is equal to. Y in this case is just equal to x squared. So we're going to write that x squared in there. Minus 3x equals 0. You're going to have 3x to the 4th power minus 3x equals 0. We can factor out a 3x out. We're left with x cubed minus 1 equals 0. So you can see here that x will equal to 0, and then x will equal to just 1. All right, so now that we have these two x values, we need to figure out what the y values are. So I'm going to plug them back into the original. So first, when x is equal to 0, plug them in, y equals 0 squared, so you get 0. So one of the points is 0, 0, so that's one of our candidates. And x is equal to 1. I'm going to plug in y equals 1 squared. You're just going to get 1. So this is going to be equal to 1, 1. Okay. So now again, we do need to find our z values. We will plug them in later. So right now, these are going to be the two candidate points that we're going to plug into this determinant. Okay, so we need to classify them because I don't know. Could be a saddle point. It can be a positive, a maximum, or a minimum. So that's what we're going to use now, our determinant formula. So we're going to have d is equal to f sub xx. Oops. Times f sub yy minus f sub xy. So f sub xx is just 6x. F sub yy is 6y minus negative 3. So you're going to have 36xy plus 3. Okay, so this guy, oh, squared. I forgot the squared. Okay, so now this is going to change things because this should be a minus and this should be a 9. Okay. All right, so this is going to be our d value. So now we need to test all the points that we get. Okay, so now the first point is 0, 0. So let's plug in 0, 0 and see what we get. So so d is equal to 36 times 0 minus 9. This gives me negative 9. So if we look up here, our d value that we got is negative. We are in case part C. That means this is a saddle point. So at 0, 0, f is saddle. Okay. And then let's try out 1, 1. So I'm going to take d is equal to 36 times 1 minus 9. So this is going to give me 36 minus 9, which equals 27, which is a positive number. Okay, so what this means is that you can have you can either have a maximum or a minimum. Okay, so that's either going to be A or B. So now we're going to look at our second derivative. Okay, so our second derivative was this guy. And what we're going to do to our second derivative, we're going to plug in 1, 1 into the second derivative. So that's 6x, so 6 times 1 is 6. 6 is a positive number. So when they're both positive, you're going to have a local minimum. Okay, so f is a local min. All right, so here we go. That's how we classify them. Now, one last thing that you want to make sure that you do is you want to make sure that you plug in these values to get your z value. So let me start off by plugging in f of x, f of 0, 0. So you get 4 plus, then it's 0 plus 0 minus 0. So you get 4. So the point is 0, 0, 4. Okay, so this is the point. This is the saddle. Okay. And then let's plug in f of 1, 1. So you're going to have 4 plus 1 cubed plus 1 cubed minus 3 times 1 times 1. So this gives me 4, 5, 6 minus 3 gives me 3. So the point is going to be 1, 1, 3, and this is going to be a minimum. And usually remember, the z value is the thing that's the minimum, right? So the minimum point is actually 3. The point itself is going to be a local minimum. All right? So that's how you would do it. So first step, take your critical points, okay? Solve a system of equations. Get your second derivatives ready. And then find the value of d, plug them in, and then classify them. Okay. One note that I will tell you is that not all the time are you going to get an actual nice with x's and y's. You might just get a number, and then the point will just classify itself. All right. So now let's try this example. All right. So find the local max, min, and saddle points for this particular problem. Okay. All right. So now let's go ahead and try it out. So let's take the partial derivatives first. All right, so f sub x. All right, so the derivative with respect to x is going to be 4x cubed minus 4y. And we're going to set this guy equal to 0. And then f sub y is going to be 4y cubed minus 4x. Okay, and we're going to set this guy also equal to 0. All right. I'm going to get our mixed partials, our partials ready. So f sub xx is going to be 12x squared. F sub xy would be negative 4. And f sub yy is going to be 12y squared. So I'm going to get these ready, put them on the side. All right, and now let's solve the system of equations. So the first thing I'm going to do is I'm going to move the 4y over, so I get 4x cubed equals 4y. So you get y equals x cubed. All right, and now let's plug it into the other one. So you're going to get 4y cubed. Oop, that's wrong. 4x cubed minus 4x equals 0. All right, so I'm going to get 4x to the 9th power minus 4x equals 0. So what you can do here, you can take out a 4. All right, so you can take out a 4, and then you can take out an x, and I get x to the 8th minus 1 equals 0. Okay, so 4x is equal to 0, and also x 8th minus 1 is equal to 0. So you get x equals 0 as one of them, and then I move the 1 over. Now, be very careful when you have an 8th power, because here we're going to take the 8th root. Whenever we take a root that's to the power, that has a root that's an even power, what we're going to have to do is add plus or minus. just like we had a square root, you're still adding plus or minus here. Let me make this a little nicer. So here we're going to have plus or minus the 8th root of 1. So x in this case will be plus or minus 1. So you got 2 x values right there. All right, so now what we're going to do, we're going to plug all of these 3 points back into this relationship right here. So x equals 0. We're going to get y equals 0 cubed, which is just 0. So we got the point 0, 0. You're going to plug in x equals 1. We got y equals 1 cubed. That gives me 1. So we got the point 1, 1. And then we're going to plug in x equals negative 1. So we got y equals negative 1 cubed equals 1. Negative 1. Sorry. That's correct. X equals negative 1. So we got the candidate negative 1, negative 1. So we got 3 different candidates, 3 different points that we got to classify. All right. So now all we got to do is find our determinant. So I'm going to take d. This is equal to the partial second derivative of x, then y, and then xy squared. So you're going to get, what was it, 12x squared times 12y squared minus mixed partial negative 4 squared. So this will give me 144 x squared y squared minus 16. All right. So this is going to be my determinant, what I'm going to be testing all these points into. So again, 0, 0 seems pretty easy. Okay, so I have 0, 0. Plug them in there, so I'm going to have 144, 0 squared minus 16. This gives me negative 16. It's less than 0, so this is a saddle. Now we're going to plug in 1, 1. 144, 1 squared minus 16. 144 minus 16. This is a positive number. So it can either be a maximum or a minimum. So we're going to use the second derivative, which is just 12 times 1 squared, which is also a positive number. So they're both positive. This means this is going to be, so if it's a positive, it's going to be a minimum. And then we're going to look at negative 1, negative 1. So 144, negative 1 squared minus 16. Notice that this is going to give me exactly the same thing. Still a positive. F sub xx, plug in the negative 1 in there. You still get a positive. So this one's also going to be a minimum, a local minimum. All right, so that's how we classify them. Also, don't forget about your values of z, so that way you have all the points complete. So I'm going to go ahead and plug them in. So at 0, 0, so f of 0, 0. Okay, I'm going to plug it in, so it's going to be 0 to the 4th plus 0 to the 4th minus 4 times 0 plus 1, which gives me 1. So the whole point will be 0, 0, 1. So remember, that's a saddle. If I were to plot it, it will be a saddle. I'm going to plug in 1, 1. Okay, 1 to the 4th, 1 to the 4th minus 4 times 1, 1 plus 1. 2 minus 4 plus 1. This is going to give me negative 2 plus 1, which gives me negative 1. So the answer here will be 1, 1, negative 1. And then finally plug in negative 1 in here. Negative 1 to the 4th, negative 1 to the 4th, minus 4 times negative 1 plus 1. It seems like you're going to get exactly the same thing, I think. Yeah, you're going to get the same thing. So you're going to get negative 1, negative 1, negative 1. All right, and that's how you would do them. This is a saddle point. These two are your minimum points.